Hi, everybody. We're working through CAASPP practice today. I'm working through the calculator section. So above here, 1 through 8 is non-calculator, but in this one, you're allowed to use the Desmos calculator. So I have that open here. So we'll use that for these problems if we need it. So it says, Cheryl claims that any irrational number squared will result in a rational number. So first thing I need to know, what's irrational and rational mean? So irrational, this word here, irrational means a number that has an infinite number of decimals, right? So I like to think of these as like crazy numbers. So something like square root of 2 is an irrational number. The decimal goes on and on forever. So decimal forever, and it never repeats itself. Kind of cool. So non-repeating is what we would say, right? So another number that is irrational is a number like pi. Oops. A number like pi is irrational as well. So 3.14159, it goes on and on forever. It never repeats. A rational number is anything that we can write as a fraction or a whole number. So fraction or whole number. So that's a number like 4, right? 4 is a rational number, or 4.5 is a rational number. So 4 or 4.5, or let's say 9/2. 9/2. If it ends, it can have a decimal as long as it's not a decimal forever, right? And it's not repeating. So even if we had like 7/9, that is a decimal forever. It's 0.77777. It's even keeps going. This 8 is just rounded. It goes on forever and ever and ever. So this is a rational number as well because we can write it as a fraction. There's no numbers that we can write in order to make our answer equal pi, right? Pi or square root of 2, like these numbers up here, are decimals that go on forever and ever, right? So irrational, you know how irrational kind of means the word, kind of means crazy, right? If you made an irrational decision, you make like not a smart decision, right? Then irrational means that you made it, that this number like goes on forever. There's no pattern to this number, okay? So part A, drag an irrational number, right? So a crazy number into the first response box that when squared will result in a rational number. So we want to take an irrational number and square it, right? Take it to the power of 2, and we want that answer to be a rational number, like a normal number. So looking at this one, if I go ahead and put this in parentheses and then square it, notice that when I square it, it becomes 2. That makes sense because the square root and the square root cancel and leave me with just 2. So I could take this one here and drag it into this box. Another one that I could take and move is this one here, right? That one could move as well. If I do show you here the square root of 3 and then divided by the square root of 2, I'm gonna go ahead and take away this part. You'll see that it equals 1.5, a normal decimal number, right? Like it ends, it does not go on forever and ever. That's because square root of 3 squared would be 3, and square root of 2 squared would be 2. So 3/2 would be 1.5. So these two numbers could go in there. So you have two possibilities. Either one you can drag in there. For part B, it says drag an irrational number. These are all irrational numbers into the second response box that when squared will result in an irrational number. So basically they're saying like, if you square it, it won't fix the problem. So pi squared, let's check out what happens to pi when we square it. When we square pi, it's still an irrational number. It's not repeating, it's going on forever and ever. So we could say, okay, I could take pi and put it in there, right? You also could take square root of pi and put it in there, because if you think about what would happen, square root and square would cancel, but then you just have regular pi. Pi is still irrational. So you could put both of those in there. You also could put these in there, but I think these are the more obvious answers here. So this is purely based on the definitions of irrational and rational. I can use my calculator to work through that. All right, let's look at number 10. Number 10 says, a train travels 250 miles at a constant speed, x in miles per hour. Enter an equation that can be used to find the speed of the train if the time to travel 250 Miles is 5 hours, right? So we know speed is miles per hour, right? So X equals miles per hour. Right? It says enter an equation that can be used to find the speed of the train if the time to travel 250 miles is 5 hours. So if this is my speed is equal to miles per hour, then I know I had 250 miles over 5 hours. So miles per hour. And I could use that as my equation. So X equals 250 over 5. Right? So that is an equation because it has an equal sign. But you could simplify this. You could also write it as X equals 150. However, since it says enter an equation that can be used to find the speed of the train, I would enter this one because we haven't used it yet. When we do this one here, we've already used it. So this would be the correct answer for number 10. Alternatively, if you're trying to think of like miles times speed would give you the hours, you could say, okay, it's going 250 miles per, it's going on 250 miles, and we're going to multiply it times its speed, right? Multiply times its speed. I would need to put miles on the bottom in order to get hours out. Remember, if we would cancel these like this. So that would mean I would have to put X, my speed, on the bottom here. And that would be equal to my hours, 5 hours, right? If you think about it this way, you could write 250, this is a 1. So we're going to put these together. 250 times 1 would be 250 over X equals 5. So alternatively, you could write 250 over X equals 5 here. This is just another way to solve it if you're thinking about it in a different way. So there could be multiple correct answers in this box here. I'd say this one is just as good as that one there. Cool. All right, let's look at number 11. It says click above the numbers to create a line plot for the given % chances of rain in different cities. So they give us all these numbers and they want us to put it on this dot plot here. So 65, 65, I'm going to mark here 65, 65. When you click on it, it will probably either fill it in or make an X there. So 65, 65, 70, 70, 80, 80, 80, 80. There are 4 80s, 185, 3 95s, 1, 2, 3, and 1 100. Just like that. Seems simple. It is simple. Remember, this is doing math all the way from like middle school math all the way up to high school math. So some questions will feel really easy, and that's okay. All right, number 12. The formula for the rate at which water is flowing is this. So we have the formula, R equals V over T, where R is the rate, V is the volume and in gallons, and T is the amount of time in seconds for which the water was measured. Select an appropriate measurement unit for the rate. So this is the rate here. V, remember, is in gallons, and T, remember, is in seconds. That's what they tell us. V is in gallons, T is in seconds. And so this is gallons over second. So our rate is gallons per second. So be this one here, B. Cool. They might just be that easy. It's okay to trust yourself. All right, number 13. I'm going to close this for now. We'll bring it back if we need to. Should make this bigger. All right, Emily is solving the equation here. Her steps are shown. Right, so her steps are here. Part A, click on the first step in which Emily made an error. Okay, so we're trying to figure out where she made an error. Click on the solution to Emily's original equation. So we're actually gonna have to solve it ourselves. So let's see what she did first. In step 1, so she distributed it. So this is her original equation. Okay, so she copied it down, right? So this step is correct. In step 2, I see the parentheses have disappeared, so I think she must have distributed. So I say, okay, 2x, that's 2x, 2x times 9, that'd be 18. 4 times x is 4x, 4 times 7 is 28, and she brought down the plus 2. So step 2 looks correct to me. Okay, so between step 2 and step 3, what did she do? 2x came down, 4x, 28 plus 2, she made it 26. Oh, well, 28 plus 2, that's not 26, that'd be 30, right? So here is her error. So it says click on the first step. I'm going to click on step 3. Step 3 is where she made a mistake, right? So mistake is here. I'm going to click on that. It'll probably highlight it in the computer. And then from here, we need to solve. It says click on the solution. We need to actually find the solution. She said it was -4, but we know it's not because she made this mistake here. So on my paper, I'm just going to solve 2x plus 18 equals, I already checked that this was correct. So I'm going to go ahead and say 4x plus, and I know 28 plus 2, 28 plus 2, that should be 30. So this is what she should have written here was 30, right? Now I'm going to go ahead and move things across the equal sign. So I'm going to go ahead and subtract 2x. Gives me 18 equals 4x minus 2x is 2x plus 30. I'm going to subtract that 30 over here. I get -12 equals 2x. Divide by 2, divide by 2. X equals -6. X equals -6. I see that as one of my answers, so I would click on that as my solution. Here. So number 13, looking for her mistake and then solving it correctly ourselves. All right. 14, we're going to skip. This is recursive functions. We haven't gotten there. We're not going to worry about 14, so you're good. What you would need to do in order to like skip it, because you have to answer every question, is you would have to put like one answer in each box. So you can make a something like that. We're going to go ahead and skip this. Yeah. Cool. All right. 15 says, a store sells used and new video games. New video games cost more than used video games. Well, that makes sense. All used video games cost the same. All new video games also cost the same. So the used ones cost one price and the new ones cost another price. Okay. The new ones are more expensive. So maybe the new ones are, $50 and the used ones are $30 or something. Omar spent a total of $84 on 4 used video games and 2 new video games. Sally spent a total of $78 on 6 used video games and 1 new video game. Okay, so Omar spent 84, 4 used, 2 new. Sally spent 68 on 6 used and 1 new. And Janet, our third character, has $120 to spend. So it says, enter the number of used video games Janet can purchase after she purchased 3 new video games. So in order to do this, we need to know the price of the used games and the new games. So I see that there's 2 situations that are like complete, I would say, which is Omar has money, has number of used and new, and Sally has her money and 6 used and 1 new, right? So we could write an equation. If I say the used is X and the new is Y, I could say, okay, Omar's situation is $84, got him 4 used and 2 new, right? That's Omar's situation with X and Y. And then Sally's situation, Sally, they spent $78 and got 6 used is X, so 6X, and 1 new, so 1Y, like that. Right? So I could do like elimination and like change these into things, but since I have the graphing calculator Desmos, I should just put these onto Desmos like this. I'm going to go ahead and clear out all those other things I was doing. Okay, and I'm just going to type in 84 equals 4x plus 2y. And I'm going to press home. I don't see it. I'm going to zoom out. Oh, there it is. Okay, I have my blue line here. And then I'm also, that's Omar's situation. I'm going to put in Sally's situation too, 6x plus 1y. So I see there are two situations here, and I need the X and Y to be the same. So I'm looking for that solution where they come together, where they're the same. So I'm going to click there. And that's telling me X comma Y. So 9 comma 24 is X comma Y. So that tells me X, my used games, are $9. So used equals $9 and new equals $24. Right, so used games, new games. And then it says enter. Okay, so now we know how much they cost. So we can go back to Janet, which was our question. Enter the number of used video games. So we want to know how many she can buy after she purchases 3 new video games. So she has $120. 3 new games is going to be 24 times 3, $72. So I'm going to subtract from here $72. So she's going to have $48 left after she buys. So after she buys the 3, she has $48 left. And then the used games are cost $9. So now I'm going to do 48 divided by 9. So I know like 9 times 5, that'd be $45. So she'll have a little bit of extra money left over, but she'll be able to buy 5 video games, right? So it says enter the number of used video games. You literally just hit this button, punch that button one time, and put a 5 right there, and then move on to the next problem. So that is number 15.